Welcome to Brain Vision.
Hi everyone, so what we have is a rigid tank of volume 0.3 cubic meters with saturated water that's at 200 degrees Celsius, and this rigid tank has a valve at the bottom. So what we're asked to find is the heat transfer when one half of the mass inside the tank has been taken out, and we are assuming that this is an isothermal process. So what we know is the volume of this tank is equal to 0.3 cubic meters, and the initial temperature is equal to 200 degrees C. It is saturated water, and the total mass leaving is going to be one half the initial mass that's inside, and we're asked to find the total heat transfer. So what we can do actually is just go to our tables, table A4 for saturated water, and at T equals 200 degrees Celsius, we know that the specific volume is going to be equal to 0.001157 cubic meters per kilogram. We'll also know that specific internal energy U is equal to 850.46 kilojoules per kilogram. Go ahead and fix this 5 right here. And we also can solve for H, and we know that specific enthalpy is 852.26 kilojoules per kilogram. Now, all of these quantities are of basically this is VF, UF, and HF in the table, and the reason why it is because we are dealing with saturated water, so we can go ahead and use the F term. What we can do now is solve for the initial mass inside the tank. Now we can just use that the mass is equal to the total volume over the specific volume, and we know these quantities, and what we can do is solve for M1, and that gives us a mass of 259.29 kilograms. Now we're going to do a mass balance. So our system is going to be defined as the rigid tank. So what that means is the mass coming inside the tank minus the mass leaving the tank is equal to the change in mass of the system. Now we have no mass coming in, right? But we do have mass leaving, and we're going to call that ME. So that negative ME is going to be equal to the change in mass of the system. So that's M2 minus M1. Now what we can do is just solve for ME. So ME would just be equal to M1 minus M2. Now recall we also had this condition where we're looking at the amount of heat that must be transferred by the time one half the total mass has been withdrawn. So what this means is that we actually know what ME is in terms of just M1, and ME is equal to one half of M1. So this means that we can actually solve for ME directly because we know the initial mass. And we know the initial mass was 259.29 kilograms. So therefore, our mass exiting is going to be equal to 129.65 kilograms, which is just half of that. So this means that we can actually solve for M2. So M2 is just going to be equal to ME or M1 minus ME. And that's also equal to 129.65 kilograms. So now what we can do is do an energy balance, and we can say that the energy coming into the system minus the energy leaving the system is equal to the total change in energy of the system. Now remember that system is that rigid tank. So what we can say is the heat transfer coming in minus the energy that's leaving due to the mass that's leaving is equal to the change in internal energy of the system. Now I'm just going to solve for Q in. Q in is that heat transfer, which is going to be equal to M2 U2 minus M1 U1 plus ME HE. Now we actually have all of these quantities, M2 and M1 and ME we just solved for. U2 and U1 we looked up in the table, and HE we also looked up in the table. So what this means is that we have everything we need to solve for Q in, and we get a total heat transfer of 241 0.87 kilojoules. And that's our final answer.